Hello viewers, you're welcome once again. We see under logic, Christ Almighty God's algebra. In our last tutorial, we treated law of absorption by conjunctive statement. Today we are going to treat law of absorption by disjunctive statement. Let us start. Law of absorption. P or brackets P and Q is equal to P. So this is an example of law of absorption by disjunctive statement. P or bracket P and Q is equal to P. What makes it law of absorption by disjunctive statement is because of this or connective that connects first disjunct and second disjunct P and Q. For disjunct P and second disjunct P and the Q. So by the reason of this connective, it is called disjunctive statement. So because of it is disjunctive statement, that's why it's called law of absorption by disjunctive statement. We are going to prove this statement that P or bracket P and Q is equal to P. Proof. Suppose P or bracket P and Q is equal to P. We assume that statement is true. That means P or bracket P and Q is equal to P. It is a true statement. We assume that it is true. In saying that when it's this equation, whenever the left hand side of the equation is true, the right hand side of the equation must also be true. In the same vein, whenever the right hand side of the equation is false, also the left hand of the equation must also be false. He said that they are logical equivalent, I mean they are equal. So if it is true that these two sides of equation they are equal, and this equation that two sides of equation they are equal, if they are true, we can also transform it to conditional statement and it will still preserve truth. So if and only if P or bracket P and Q, if and only if P is tautology, being justified by logical equivalence. We have now transformed this statement, this equation, to biconditional statement and it still preserve truth. In the sense that whenever the left equivalent is true, also the right equivalent must also be true. In the same vein, whenever the right equivalent is false, also the left equivalent must also be false. So if you write this statement, since this is the condition that they have equal value, the both sides of the equivalent they have equal value. So if you write this statement, that's not possible getting falsity, always truth. You say that is tautology. Being justified by logical equivalence, that means it is true logical equivalent that we transform this equation to biconditional statement and it still preserve truth. If and only if P or bracket P and Q implies P is tautology, being justified by logical implication. Biological implication. You see that you have now transformed this biological statement to conditional statement and it still preserves truth. It still preserves tautology. In the sense that whenever the antecedent is true, the consequent must also be true. So if this is the case, if we validate this statement, there is no possibility of falsity, always truth. We say that it is tautology. Being justified by logical implication is through logical implication that we transform this biological statement to conditional statement and it will still preserve tautology. If and only if P or bracket P and Q is logical implication of P, we then derive that P or bracket P and Q is logical implication of P. That means it is certain that P or bracket P and Q exist. In the sense that we derive it through principle of logical implication. In the sense that since this is a question statement and it's tautology, so this antecedent is proper implication of the consequence P. Since that is the case that the antecedent is proper implication of P, you say it is certain that antecedent exists. Since it's certain that antecedent exists, you say that antecedent is logical implication of the consequence. That's why I say that P or bracket P and Q is logical implication of P by principle of logical implication. If and only if P or bracket P and Q is equal to P and P or bracket P and Q. Now, he said that equated the logical implication with itself. That means we said that logical implication is equal to itself. And it is true that logical implication is equal to itself. In the sense that whenever the left-hand side of logical implication is true, also the right-hand side of logical implication is also true. In the same vein, whenever the right-hand side of logical implication is false, also the left-hand side of logical implication is also false. We say that they are logical equivalents. I mean, they are equal. So it is true that they are equal, being justified by identity. That means the sameness. Being justified by identity. So if and only if P or bracket P and Q is equal to P or bracket P bracket P and Q or bracket Q and not Q. You see that we have, what we did here is that we OR this P and Q with Q and not Q. That means falsity is equivalent to P and not Q is equivalent to falsity by law of complement is equal to F. So F or with any term is same as that term. So it's same as P or Q. You see that the left hand side of the equation is equal to the right hand side of the equation because it's still P or bracket P and the Q. So being justified by law of identity. It is two law of identity that we or P and the Q with falsity. That means Q and not Q. Being justified by law of identity. So if and only if P or bracket P and Q is equal to P or bracket P upon not Q or bracket Q and not Q. Now we have this P and the Q, the conjunctive statement has now been transformed to conditional statement. That means it's now P upon not Q. That means not Q implies P. Not P, not that means not Q implies P. And it's no more equivalent to, there are no more law. It's not grace because the right answer of the equation now is not greater than the left answer of the equation. Because the right answer of the equation now is equal to P or Q. It says that this is falsity. Falsity all anytime you say things like that, that means this is P or Q. As if P as a P or Q. And P or Q or P is setting as P or Q. So it's not more equivalent to this, the left answer equation now. It's not intensification of the left answer equation. You see, is intensification of P or bracket P and the Q. Being justified by Christ Almighty God's grace. It is through Christ Almighty God's grace that we transform this conjunctive statement, to conditional statement. So being justified by Christ the Almighty God's grace. We continue. Say if and only if P or bracket P and Q is equal to P or bracket P or bracket Q and not Q upon not Q. We see that we have now distributed this not Q to this to the second disjunct or statement. That means this, you have distributed this not Q to Q and the not Q. That means the second disjunct. That's why we have P or bracket Q and not Q upon not Q. And it's still equivalent to P or Q. That means the right answer equation is still equivalent to P or Q. We say that this is equal to Q. That means Q or Q and not Q upon not Q is equivalent to Q. Then Q or P is P or Q. Then P or Q or P is P or Q. So it's still intersection of the left hand side equation because it is equivalent to P or Q. Why is equivalent to P? So then he said is intensification of P or bracket P and the Q. Being justified by description of implication. By description of implication. It is through its of implication that we distribute this not Q to the second disjunct. And is still anticipation of the left hand side of the equation. That means or P or bracket P and the Q. So being justified by distribution of implication. So being justified by distribution of implication. We go to this side. We said that we are going to revise this bracket Q and not Q upon not Q to conjunctive statement. Reason is that this not Q is generated from conjunctive statement. This P and Q is being generated from the conjunctive statement. That means this Q, P upon not Q, is being generated. This not Q is being generated from the conjunctive statement. So when we want to revise it, it's going to be in conjunctive statement. That means you say if and only if P or bracket P and the Q is equal to P or bracket P or bracket Q, bracket Q and bracket Q and not Q. Yes. So that is that. You see that it's now equivalent to the left hand side equation. It's not more grace now. Because now the both sides of the equation are now equal. No one is greater than each other, or no one is now specific to each other. No, they are now logical equivalent. It says that this is Q and not Q is equal to F. When F is and with n term, is set as F. So when F is all with this P, it becomes P. P or P is P. So, and this letter equation is also equal to P. Based on our hypothesis, is equal to P. So, but this question statement is being transformed to question statement through Christ Almighty God's grace. So it's being justified by Christ Almighty God's grace. Being justified by Christ the Almighty God's grace. So if and only if P or bracket P and the Q is equal to P or bracket P or bracket Q and the T. And the C law, because they're still equivalent, the two sides of the equation are still equal to each other. So you see that this Q and not Q is associated with T. That means by law of complement, Q and not Q is equal to T. That's why it's associated Q and not Q with T. Being justified by law of complement. So if and only if P or bracket P and Q is equal to P or bracket P or T. You see that Q and T is it's F, it's F, it's not T, it's F. It's F, it's F. Know that Q and not Q is equal to F. So when F is AND with any term, is same. When F is AND with any term, same as F. So that's why I split this Q and F with F. B justify by law of constant. It's two law of constant that split this Q and F with F. So B justify by law of constants. If and only if P or bracket P and Q is equal to P or P. You see that this P or F is associated with P. In the sense that whenever F is all with any term setting at that term by law of identity. So it's been justified by law of identity. Go to this side. So if and only if P or bracket P and Q is equal to P. We see that P or P is equal to P by law of idempotent, being justified by law of idempotent, being justified by law of idempotent. You see that we have now proved our hypothesis that P or bracket P and Q is equal to P. We then conclude, say thus P or bracket P and Q is equal to P. Having proved the hypothesis, our assumption, we are going to prove the converse. So by the principle of equality, we then establish that P or bracket P and Q is equal to P when we prove the converse. So we say conversely, P is equal to P or bracket P and the Q. You see that the P ID right answer of the equation here has now become P ID left answer of the equation here. Then P or bracket P and Q ID left answer of the equation here has now become P or bracket P and Q ID right answer of the equation here. Instead that it is converse. So we're going to prove the converse so that we can be able to establish by the principle of isomorphism, it can be able to establish that P or bracket P and Q is equal to P. Is law of absorption by disjunctive statement. Then we say suppose P is equal to P or bracket P and the Q. Now we are showing that the statement is true. That means it is equation. The both sides of equation they are equal and are logical equivalent. So since they are equal, it means that whenever P is true, P or bracket P and the Q is also true. In the same vein, whenever P or bracket P and the Q is false, also P is false. We say they are logical equivalent. Since they are logical equivalent, they can also transform it to biconditional statement and it will still preserve truth. So if and only if P, if and only if P or bracket P and the Q is tautology, being justified by logical equivalence. Now we have now transformed this equation to biconditional statement and you still preserve truth. It still preserves truth. It says that whenever the left equivalent is true, the right equivalent must also be true. Whenever the right equivalent is false, also the left equivalent must also be false. If we evaluate this statement, there is no possibility of getting falsity. Always truth. He said that it is tautology. Being justified by logical equivalent, he said that this equation is being transformed to biconditional statement to logical equivalent. That's why I say it's being justified by logical equivalent. If and only if P implies P or bracket P and the Q is tautology, being justified by logical implication. You see that we have now transformed this biconditional statement to conditional statement and it still preserve tautology. In the sense that whenever the antecedent is true, the consequent must also be true. So if that is the case, if you read this statement, there is no possibility of falsity. Always truth. You say that it is tautology. Being justified by logical implication. It is through logical implication that we transform this biconditional statement to conditional statement and it still preserve tautology. Let's continue to this side. So if and only if P is logical, P is logical implication of P or bracket P and the Q. Now, by the principle of logical implication, we then derive, since this is a conditional statement and it's tautology. So, by the principle of logical implication, we then derive that P is logical implication of the P or bracket P and the Q. In the sense that since this is logical implication, so this is a conditional statement and is tautology, then P is a proper implication of the P or bracket P and the Q, the consequence. Assistant is logical implication of the consequence. So we then say that it is certain that P exists. If you say that P exists, you say that P is logical implication of P or bracket P and Q. That means the antecedent is logical implication of the consequence. So by principle of logical implication. So if this is true, also this also must also be true. Say P is equal to P. That means P is equal to itself. So P is equal to itself. self. So it is true that P is equal is self. It said that they are logical equivalent. So whenever P is true, P is true. Whenever this P is true, this P is so this P is false, this P is false. We justify by identity, that is the sameness. We justify by identity because they are logical equivalent. So if and only if P is equal to P or P, that means you are not split this P with P or P. We justify by law of idempotent. We justify by law of idempotent. If and only if P is equal to P or bracket P or bracket P and Q or not Q. Now you have this P, the second disjunct, has now been AND with tautology, that means Q or not Q. You have AND it with Q, you have AND it with Q or not Q, and it's equivalent to T. And when T is AND intersecting at that time, so it is still P. P or P is P, which is equal to the left side equation. So it's still law. Being justified by law of identity. It is through law of identity that we AND this P with tautology, with Q or not Q. So it being justified by law of identity. Let's continue to this side. So if and only if P is equal to P or bracket P or bracket Q upon Q. That means we have now transformed this disjunctive statement to conditional statement and it still preserve equivalent. In the sense that this is this disjunct is equivalent to logical, is equivalent to implication. This disjunctive statement P or not Q is equivalent to Q upon Q in conditional statement. In the sense that it is here is tautology, there is also tautology. So, and if you watch now, it's no more equal to the right left hand side equation now. It's no more equivalent to the left hand side of the equation. In the sense that this Q upon Q is tautology. Tautology or with any term is saying, okay, sorry, this is not, it is AND. Sorry, it's AND. So you see equivalent, sorry, it's AND. It is P AND. So it's P AND. So it's still equivalent to the left hand side of the equation because it's Q upon Q, that means tautology AND with any term is same as that term. So it's P and bracket Q upon Q is P. P or P is P. So it's equal to the left side of the equation. So being justified by first edge case law. It's through first edge case law that we transform this disjunctive statement to conditional statement being justified by first case law. If and only if P is equal to P or bracket P and P upon Q P upon Q and Q. You see that you have now distributed this Q to this first conjunct P. That's why we have P or bracket P upon Q and the Q, and it's still equal to P. In the sense that this P upon Q is equal to not Q or P, not Q or P, and P is equivalent to P and the Q. So P and the Q or P is equal to P. So it's still law. So it's justified by the law of implication. It is the law of implication that we spread this implication to the first conjunct P. That we have now P or bracket P upon Q and the Q. So it's justified by distribution of implication. If and only if P is equal to P or bracket P. Now I'm going to transform this Q to, I'm going to transform it to the disjunctive statement. I'm going to transform it to disjunctive statement. That means this P upon Q, that is a conditional statement. So since I'm going to transform it to the disjunctive statement, since this Q is being generated from the disjunctive statement. So whenever I want to transform it, it's going to be in disjunctive statement. So you have P or not Q and the Q. So we have now transformed it. It's still logical equivalent because the both set of equations they are equal. In saying that this P or not Q and Q is P and the Q, and P and Q or P is equal to P. So being justified by first case law, it's two first case law that will transform this conditional statement to disjunctive statement. So being justified by first case law. If and only if P is equal to P or bracket P and the Q. You see that this P or not bracket P or not Q and Q has now been substituted with P and the Q by second case law. By second case law, let this P or not Q and bracket only bracket and Q with P with bracket P and the Q by second case law. Being justified by second case law. We have now approved the statement. Our converse, we have now approved our converse. That means P is equal to P or bracket P and the Q. So we then conclude, say, thus Thus, P is equal to P or bracket P and the Q. Now, having proved the converse by the principle of externality, we then establish that P or bracket P and the Q is equal to P is law of absorption by disjunctive statement. Then conclude say therefore P or bracket P and the Q is equal to P is law of absorption by disjunctive statement. So we have now proved that law of absorption by disjunctive statement exists. So at this juncture, we shall draw our curtain. Thank you, viewers.